To go through the Unit 1.8 handout today, we're going to be talking in particular about sound pressure in pascals and sound pressure levels in decibels. I'm trying to make that connection. Roman numeral number 1 says, given an acoustic pressure at a specified distance from a source, calculate the acoustic pressure at a quarter, half, twice, and 4 times the specified distance. So the first question then is, how does the pressure, sound pressure from a spherical source, acoustic source, change with distance? So if we have our source here in the center, then the sound travels outward from these, right? In these concentric circles, and these would be like the wave fronts on spheres, getting larger and larger as the sound traveled away from whatever is our loud source here in the middle. This is if it was radiating the same in all directions, which is simplified, but it's a good model for us right now. Okay, so the letter R we're going to be saying is the radius of the sphere, but it is also the distance we're talking about relative to the from the source. So for example, if I have my little microphone right here, then it would be a distance R away from the source. That's what I mean by R. I'll try to draw one more circle. See if I can get it. About the same. Okay. So let's say that that's a distance R. And then let's say we're comparing the sound at that distance, light green R, with the sound, oops, that's reaching out to here. We'll have that be our dark green R. So we'll call that R2, and we'll call this one R1. Okay, so they were comparing the sound at different distances away from the source. Okay, so the way this works is if R2 is twice the value of R1, if we are twice as far away, then the pressure, the sound pressure at 2, so P is going to be the sound pressure in pascals. The sound pressure is going to be half at R2, the value that it is of R1. So my little subscripts 1 and 2 here are talking about these two different locations. Okay, if R2 is twice R1, the pressure there, P2, will be half the pressure of P1. Okay, now let's go the other way. If R1 is half of R2, then the pressure at 1 is, at point 1 is twice the pressure at point 2. Okay, those are saying the same thing, just in different ways, in case that is helpful. And from that, we see the relationship is that the pressure, the sound pressure, is inversely related. When one goes up, the other one goes down to the distance from the source, the R value. Okay, so we have an inverse relationship there. Now, if you can't remember it, you know exactly these words, then you can use your own intuition and say, okay, am I closer to the thing making noise, or am I farther from the thing making noise? If I'm closer, it has to be louder, so the pressure has to be more. If I'm farther away, it has to be quieter. I know that from my experience. So then the pressure farther away will be less. So go ahead and use that intuition to help you know if it should be increasing or decreasing. Okay, so now we're going to do an example. Number 1. Okay, so this is for both number 1 and number 2, this example. 2 meters from a loud source. Okay, the pressure is equal, so One way to write this is when R equals 2 meters, pressure equals 200,000 micropascals. Now the first question is, what is the pressure at R equals 4 meters? Okay, so you can draw this same kind of picture. You can say, here's my loud source, and here's 4 meters away. Or sorry, 4 meters and 2 meters. At 2 meters away, it is 200,000 micropascals. I double the distance I am away from the source. That means that the pressure will be half as much. So it's a factor of 2 because the distance changed by a factor of 2, but it has to be quieter because I'm farther away. All right, so it will be 100,000 micropascals, which is B. Number 2 says, what is the pressure at half a meter? Okay, I'm going to go ahead and draw this a little bit bigger now. Okay. Let's say 8 meters is out here, and then 4 meters would be half of that, and then 2 meters would be half of that, and then 1 meter would be half of that, and then a half a meter would be half of that. Okay, so we've been told for this case that here at 2 meters, we have 200,000 micropascals. And we just found in number 1 that at 4 meters, it would be 100,000 micropascals. That's from question number 1. So now we're coming closer. So it has to be getting larger. So when I go from 2 meters to 1 meters, that's half the distance. So it will be twice the sound pressure level, or sound pressure, sorry. And then if I go from 1 meters to half a meter, then it was going to double again. So a factor of a quarter is the same as, in change in the distance is the same as 4 times as much in the pressure. Okay, so that is C. Now, we could also go the other way to 4 times the distance. At 2 meters, it's 200,000. 4 meters, it's 100,000. That means out here at 8 meters, it would be 50,000 micropascals. All right, so now on the bottom of that page, number 2, Roman numeral number 2, it's talking about the relationship between sound pressure levels in decibels and sound pressure in micropascals, or it's called acoustic pressure here. So again, the little p is the sound pressure or the acoustic pressure. The reference pressure that is used for sound in air will always be, that's in the denominator of that equation there, will always be 20 micropascals. Okay, and then the SPL is the sound pressure level. Those are our different variables that we're talking about here. Sound pressure level will be in decibels. The sound pressure will be pascals, and we specifically will use micropascals. So that little mu equals micro, and that is a factor of 10 to the minus 6. Okay. All right. So we have 2 equations. We have how to find the sound pressure level if we know the pressure. So it'll be 20 times log, and this is log base 10, P divided by P ref. Okay. Again, P ref will always be 20 micropascals. So if you want, it will be 20 log 10. And then it'll be your pressure, whatever's given in your problem, divided by 20 micropascals. That is true for sound in air. Now, if you undo this equation, you get how do you find the sound pressure when you have the sound pressure level? So it is the reference pressure times 10 raised to the power of SPL divided by 20. Okay, so I'm going to put a little X here for times. In scientific notation, we tend to write our numbers instead of saying like 0.02. We would say that that is 2 times 10 to the minus 2 power, or 2,000 would be equal to 2 times 10 to the positive 3 power. Okay. Or 15,000 would be 1.5 times 10 to the 4th. Okay, so the exponent there on the tens is basically telling us where the decimal is going to go. Okay, on your calculator, if you want to practice, you could do 2, and then there's an EE button, and then minus 2, and then equals. If you do that, you should get 0.02. And you can try that with all of them. This EE button here is the same as times 10 to the x. Or I'll make it different, to 10 times 10 to some number a. And a is whatever number you put in next. Okay? So that's what your EE button is doing. It's converting it to scientific notation. Okay. So these two equations here will be on your test. You just need to know how to use them, which we're going to practice right now. Okay, so turning the page over, got our little scientific notation aside here. Okay, so we have number 3. What is the sound pressure level? So that's our question, corresponding to a pressure of 2,000 micropascals. Okay, so we have our equation. Sound pressure level is 20 log 10 P divided by P ref, but P ref for sound and air is always going to be 20 micropascals. Okay, so I would put 20 micropascals down here. I'll write it as P ref first, then put in the numbers. Okay, so if I plug in the pressure now, that's 2,000 micropascals divided by 20 micropascals. Okay. And now the question is, how do you do this on your calculator? Okay, so just real quickly, if you have a calculator on your phone, if you turn it this way, you only see the basic calculator. If you use your landscape, you'll be able to see the field calculator. It has the log 10 button and the EE button. Okay, so going back to what our problem was. Okay, we have 2,000. So on the calculator, we're going to go 2,000 divided by 20 equals. Okay, so that's the first step. So let's do that on the calculator. 2,000 divided by 20 equals. So it should give you 100. Okay, then you press the log 10 button, which gives you 2, and then you times it by the 20 that was out in front, and you get 40. Okay, so let's come back here. So this 2,000 divided by 20 gave us 100. Okay, then you press the log 10 button on that. So, and that should give you 2, which is the power associated with that. And then you would times it by 20, which would give you 40. Okay, so this is step 1 on your calculator. Step 2 on the calculator is push the log 10 button, and step 3 is to multiply by 20. So I've written out what you should get at each of those steps so you can check your calculator practice. Okay, again, so step 1 is doing inside the parentheses. Step 2 is pushing the log button, and step 3 is multiplying by the 20. Okay, so we have three different steps here that you need to do. Okay, so that is 40, and the units on that are decibels, so that would give us an answer B on the handout. Okay, number 4 now is going to use the equation where we go backwards. I'm going to change color here just to keep them a little more visually separate. So In number 4, P is the question mark, the sound pressure, and the sound pressure level is 20 decibels. Okay, and then our equation is from up above on the other side of your sheet, okay, is P equals P ref times 10 to the power of SPL divided by 20. And again, P ref is always going to be 20 micropascals for our class for sound and air. Okay, so this would go, and we're putting in the numbers, the sound pressure would be 20 micropascals times 10 raised to the 20 divided by 20. Okay, so 20 divided by 20 is 1. So in this case, that would be 20 micropascals times 10, which would just be 200 micropascals, which is B. I'm going to do another one just so that you can see a little bit more how you will do it on your calculator when it's not just a nice 1 there. Okay, so here's another example of that same thing. Let's say we're wondering what the pressure is, and the sound pressure level is 75 decibels. Okay, we use that equation. P is P ref times 10 to the SPL value divided by 20. Okay, if we plug in the numbers, that's 20 micropascals times 10, and then I'll have 75 divided by 20. Okay, again, we are going to do this from the inside out. Okay, so step 1 on the calculator is 75 divided by 20. Step 2 on the calculator is going to be saying 20 EE, and then you have to enter that number in. So now those are I'm just writing it out. Now we're going to do it on the calculator. Okay, so I have 75 divided by 20 gives me 3.75. So I'm going to write that down on my paper. 3.75. So 3.75 is the number I'm going to need to put in here. So I'm going to do 20. What this means is 20 times 10 to the 3.75 power. That's what the EE button means. Okay. So I'm going to 20 time, no, not time, 20 EE 3.75 equals. Okay, and I have 112, 468, 112,468 micropascals is the answer for that example. That's what that equals. Okay. I'm going to do it again up here for this one, just so that you can see what the EE button is really doing. So I'm going to take this equation here, and on the calculator, I'm going to do, so step 1 was 20 divided by 20 equals 1. And step 2 is 20 EE1. Let's just make sure that really gives us times 10 like we expect. Okay, so 20 EE1 gives us 200, okay? So that is what the EE button is, times 10 raised to that power. Okay. All right, so hopefully those are helpful to help you know how to do those on your calculator. When you go to the testing center, you will need to have a calculator with a log and an EE button, or you will need to borrow one from the testing center. Okay. All right, now I'm going to borrow my picture that I drew up here, because we're gonna fill it in a little bit more. See if I can grab the whole thing. Copy. Okay, now let's get it over here. Good. So that saves me having to draw it again. Okay, so these micropascals, those were, that was the problem that was given above. And now the question is, what if we put those on a decibel scale? What is the difference? So I think we're going to go ahead in this video to just kind of show you where some of this comes from. So we're going to calculate these, okay? So let's do it. So let's find what is the sound pressure level at half a meter, okay? Well, we're just going to do all of them. So that means the sound pressure level at half a meter using our equation above is 20 times log 10 of 100,000 micropascals divided by 20. It's always divided by 20 micropascals. Okay, so when I plug this in on my calculator, I'm going to go 800,000, okay, divided by 20 equals 40,000. I'm going to press the log 10 button, okay, and then I'm going to times that by 20, okay, roughly 92. So this is 92 decibels. Okay, I'm going to write that right up here. Maybe I'll use a different color for writing it, just so it's a little easier to see. 92 decibels at a half a meter. Okay. All right, now let's do 1 meter. So that would be 20 log 10. We found that was 400,000 micropascals divided by 20 micropascals. Okay. All right, so again, on our calculator, 400,000 divided by 20 equals log 10 button times 20. So 86. 86 dB. And this one here is 86 dB. Okay. And now we'll do the 200 micropascals one. Okay, you would do those same things on your calculator. I'm just going to go ahead and just write the answer here is 80 dB. All right. Do you notice a pattern? What is the pattern? The pattern is that if the distance doubles, the sound pressure level decreases by 6 decibels. Okay. So using that fact, we would go from 80 decibels at 2 meters. At 4 meters, we would subtract 6. That would be 74 decibels. That's the same as if you use 100,000 micropascals in the equation. And then if we double the distance again, we would subtract 6 from 74 and get 68 decibels. Okay. And you can write out the sound pressure level equation for 50,000 micropascals and find out that that is true. Okay. Conversely, if R is half, if it's half as much, if you come closer, then the sound pressure level increases by 6 decibels. Okay, so if you started out here at 8 meters for 68 decibels, then if you came into 4 meters, you would add 6 to 74. And if you came in half again, you would add 6, etc. Okay, so that's our rule for those guys. Okay. This is in fact the problem that is in questions number 5 and 6. Okay, so question number 5 says, if the sound at 2 meters is 80 decibels, what is the sound at 1 meter? It's 86 dB, so that's D for number 5. And then what would the sound pressure level out at 8 meters be? You would double the distance twice, so you would add 6 2 times. So this would give us B for question number 6. Okay, now I'm going to show you something about logarithms. If it's interesting to you, but you can also skip this little part that I'm going to put into dark green here. Okay, so y plus minus 6 dB. Okay. One property of logs is that if you have the log of 2 numbers, a and b, that is the same thing as the log of a plus the log of b. Okay, So if I know, right, that I'm doing my sound pressure level and I have it at some P1 value divided by my Pref, okay, I'll get a number. So I'll call it SPL1. And now if SPL2 is my pressure is half as much because or twice as much because I've halved the distance, okay, then my pressure would be twice as much. And so that would be 20 times log of 2 plus 20 times log of P1 divided by Pref, based on this property of logarithms right here. Okay. Now it happens that 20 times log of 2 is 6 plus 6. Okay. So if the pressure doubles, this is your original SPL1, right, at the first location. And so if the pressure doubles, then you add 6 decibels. Okay. Let's say at another place, so this would be like at a half a meter, let's say. Let's say this is at 1 meter. Just to kind of, so at 1 meter, it was P1, and at half a meter, it would be 6 decibels more, right? But at 2 meters, it's going to be half as much. So we have a factor of a half here. Okay, so that would be, again, breaking it up based on this property of log, we would have 20 log of a half plus 20 log P1 divided by Pref. Okay, this again is the sound pressure level at 1 meter. But this, if you put in a half and do log and 20, it will be minus 6. Logs of fractions are always minus 6, or are always negative. Sorry, that's the negative comes if the argument there is less than 1. So that is why we have our plus and minus 6 dB when the distance is halved or doubled. Okay. Okay. So again, just right up here, if R doubles, the pressure is half as much, right? And the sound pressure level decreases by 6 dB. If R is halved, then the pressure doubles and the sound pressure level increases by 6 dB. Okay, this is the thing to remember about that. Okay, and then last but not least, we have Roman numeral number 4. Okay, see table 12.3 in the book, I believe it is. These have levels, A-weighted levels, which we'll talk more about when we get to hearing, of common sounds. And so you need to memorize the levels for these few sounds. Not everything on the table, but for the list. And this is not just, memorization for the sake of memorizing. It is actually very helpful to get in your brain an approximate, what corresponds to different decibels, right? What is about 20 decibels? What is about 40 decibels? What is about 80 decibels? So that then if you hear someone or read something talking about how loud a sound is, then you have some everyday experiences that you can relate it to. Okay, so that's for the test. You'll need to make sure you know that. Okay, hopefully this was helpful for you. We can do more examples as we go through and get ready. But okay, good luck.